Hello viewers, welcome back. In the last video lecture, we discussed the aromatic electrophilic substitution reactions of unsubstituted naphthalene. So where we learned the one substituted naphthalene will be the major product due to the stability reasons. Followed by we discussed the temperature and the solvent will also the influence or decide the position. In this class, we are going to talk about the monosubstituted naphthalene. So what will happen if the monosubstituted naphthalene undergoes aromatic electrophilic substitution reaction, in where the position the incoming electrophile will get substituted. That is the task now. So listen carefully. Here I took two different substituted naphthalene, that is monosubstituted naphthalene, that is 1 and 2 are the two possibilities. Here there are the Z. Here I took that Z is an orthopara directing groups. So please remember that. So we already discussed the orthopara directing groups and the meta directing groups in the monosubstituted benzene orientation and reactivity. So please go through that. That is very important, that fundamental. So that is required knowledge to understand this topic. Okay. Now, as I told you, this orthopara directing group is also called as activating group. Okay. Now, so what will happen if the orthopara directing group had substituted first position and second position? So please remember that if it is that already substituted in the first position, the incoming electrophile will get substituted at the fourth position. So finally you will get that 1,4 substitution of this naphthalene as a major product. Sometimes 1,2 also is possible, but this is a minor. Understand it? So this electrophile may substitute at second position also, but this is a minor and this is a major. Okay. So this is the fourth position and second, this third, this one 5, 6, 7, 8. Okay, these are the positions of naphthalene. Okay. Now, so what will happen if the electrophile is getting substituted or react with the two substituted naphthalene? So please remember that in this case, if it is an orthopara directing group, always this one substituted will be the major product. Sometimes you can get 6th position also. Here this is the 6th position. So preferably 1, 2 is a major. Okay. Now if you observe carefully, in the both cases the electrophile is substituted in the same benzene ring of the naphthalene. You see the Z and E, here the Z and E are in the same ring. Why didn't it undergo went for this another ring? The reason is because the Z group is an orthopara directing group. So this is an activating group. So the electron, it will push the electron towards this ring. That's why this ring is highly activated than the other ring. Okay, suppose this is the B ring and this is the A ring. Okay, so the B ring is having more rich in electrons. That's why the incoming electrophile is getting substituted in the same ring where already the substituent is existing. This kind of substitution is called as homonuclear substitution. Okay, homonuclear substitution, because the electrophile is substituted in the same ring. For example, this one I am giving one good example here, because you done this one as an experiment in your laboratory. So this is a 2-naphthol. So if you do the diazotization reaction with aryl diazonium chloride, so you see here this one azo group is getting substituted at the the first position. This is 1-phenylazo 2-naphthol. Okay, so that you have done as a experiment in your laboratory. See, the reason is the OH is a orthopara-directing group, and this also in the second position. That's why this is directing this incoming electrophile at the first position, because this is this whatever that lone pair electrons, this is flushing this electron towards this same ring, so make enrich that benzene, so and facilitate the substitution in the same aryl system. That's the reason. Okay, now we move into the this one. If Z is a meta-directing group, as you know, this meta-directing groups are a deactivating group. So let us consider this one. Z is a nitro. So nitro is a more electron withdrawing group. That as a result, what will happen? So it will withdraw the system. So the incoming electrophile will always directed to the another ring which is not substituted. You see, now it will always prefer to go the ring A, not B. Okay, ring A or B. So now this will give either the substitution at 1,5 or 1,8 like this in this position. So this is the 5th position and this is the 8th position. So you always get 1,5 or 1,8 substitution. If it is in the second case, here also the same, either 2,5 or 2,8 position, because the nitro group is more electron withdrawing group. So this the B ring, wherever this electron withdrawing group is connected in the ring, that will not allow to substitute that incoming electrophile in the same ring, because this is very weak in this pi system. So this will facilitate. That's why the electrophile will get always substituted in the other ring system. That's why this type of substitution is called as heteronuclear substitution. Hetero means different. The incoming electrophile is substituting it either at here or here. Okay, like this, 1,5 or 1,8 for the first one, and the second case 2,5 or 2,8. Now, so these are about the mono substituted naphthalene aromatic electrophilic substitution reactions. Now we see some more reactions. What will happen if the reduction of naphthalene? If you do that hydrogenation in the nickel catalyst, first it will form 1,4-diylene. So this, or you can call 1,4-dihydro-naphthalene. Okay, and if you do reduction further, so one of the ring is completely saturated. This is called as tetraline. If you do further hydrogenation, this is completely saturated, and this system is called as decalene. You see, all the pi electrons are getting this saturated. Okay, so this is decalene. Now we are going to see that oxidation of naphthalene. Here we will get different products according to the nature of reactants, that's oxidizing agents. If you use the KMnO4, the product is phthalic acid, and vanadium pentoxide, the outcome is phthalic anhydride. If it is chromic oxide or chromium trioxide, so we will get naphthaquinone, and ozonolysis we will get phthalaldehyde. I hope you understand this video lecture. So kindly subscribe and share this video lecture if this lecture is useful. Thank you very much.